Question 10. So let's have a look at the different possibilities that we could have here. So what about if it's even? Well, remember an even number is something like, let's say 2m. Right, you don't have to use the letter m, you could use x, use whatever you want to, maybe not use n. And then square that, add 2. So I'm just following this through. So if I do this, I get 4m squared, add 2. Well, this is clearly going to be a multiple of 4. So a multiple of 4 add 2 is not a multiple of 4. It cannot be, because it's a multiple of 4 add 2. Right, so that's not going to work. The other possibility is, what about if it was odd? So the number's either going to be even or odd. So that's where we use 2m plus 1. Don't forget we've got a plus 2 at the end. So if we expand this, that gives us 4m squared plus 4m plus 1 and then plus our 2. Okay, we've got 1 plus 2, that's 3. And what I'm just going to show you at the beginning is I can take a factor of 4 there and plus 3. So this is a multiple of 4, add 3. So it's not a multiple of 4. There we go, just jot that down there. It's not a multiple of 4. So therefore, that's proof, okay, because we've considered even and odd just there. So that's part I. Right, the second part. The second part, if we read the question here, it says, so the modulus of 3x minus 28. So that means that we always take that as a positive value. And it's going to be greater or equal to the value of x minus 9. So let's just write that down. So there we go. It's going to be greater than or equal to x minus 9. And the question is this going to be always true, sometimes true, or never true? So the easiest thing to do is to think about this in two possibles. Think about this as a positive. So that's 3x minus 28 more than or equal to x minus 9. So let's see what happens there. So if we do this, let's we'll take away x from both sides. We get 2x. Add 28 to both sides. We get 19. And then divide by 2. So x has to be more than or equal to 9.5. Now let's think about, well, what about if this was a negative? So in other words, it was minus 3x minus 28. So that's minus 3x plus 28 being more than or equal to x minus 9. So the easiest thing to do here, add 3x to both sides. Get 4x there. Add 9 to both sides. We're going to get 37. Divide by the 4. We get 37 over 4, which is 9.25. So x is less than or equal to 9.25, more than or equal to 9.5. Well, wait a minute, there's a gap in the middle. So if I were to take a number of like 9.3 or 9.4, then that would not be true. But it's true when x is less than or equal to this, and it's more than or equal to this. So the answer is that it's sometimes true. Now you could just try some numbers out. So if you try a number out like 8 or something, then you'll find that that's true. And then if you were to try your 9.3 or 9.4, and then you would show that it wasn't. So therefore you could come to the same conclusion. Another possible approach is just to draw a graph of what goes on. And it's probably a little bit easier to see what's going on here. Is that if you were to draw x minus 9, just there. Now if you were to draw, let's say, for example, this 3x minus 28, but a modulus of it, it will go something like this. So it kind of comes down, and it's going to jump back up again there. So it's this sort of area in here where it's below. So that value there is 9, and that would be 9.25. 9.25 in line here, 9.5 just there. Right? So maybe that's a little bit clearer. But I find this is the easiest method to do.